I'm gonna love you.
Everybody, today we're going to be doing standard deviation of a population and of a sample. So the formula for standard deviation of a population is sigma, which is kind of looks like theta, but it's just another way of saying standard deviation, equals everything is square rooted, the sum of x, this is for population, by the way, x mu, and then n, and this x minus mu squared. And now your formula for a sample is really similar. So instead of theta, we actually use s, and we still use sum x minus x bar this time. Because when you're working with a sample, you use x bar, and when you're working with population, you use mu. And it's n minus 1. So this means the sum of whatever's next to it, x equals the each term, m or mu or x bar equals mean, and n equals total amount of terms. Okay, maybe good to write this down. Okay, so I'm gonna do a couple examples to make this more easy to understand. Okay, so say I have a data set of, let's do 3, 7, and I don't know, let's go 13, right? That's my data set, 3 numbers. So we're going to say that's my whole data set, that's my population. So first step in solving a problem is to find mu, or our average, which is just 3 plus 7 plus 13 all over 3, which should equal, 23 over 3. I'm going to round it 7.6667. Okay. So that is our mu, right? That's our average of the population. So let's just plug that into our formula here. So let's do sigma equals the sum of, let's start with our first number, 3, or let's not get too ahead of ourselves. Okay, x minus 7.6667 squared all over, and since we do have 3 terms, 3, right? So let's work this out. So the sum of this, so this would basically just be x, 3 minus 7.6667 squared plus, what's our next term, 7 minus 7.6667 squared plus 13 minus, and it's the same thing, minus 7.6667 squared. But I don't have room, so I'm just going to do that, right? All over 3, which, I'm going to do this in the calculator because I don't want to do this by hand. 3 minus 7.6667 squared should be 21.7781. And remember that in stats that at least we should round to 4 decimal places is what I've heard. Okay, so 7 minus 7.6667 squared is 0.4445 plus 13 minus 7.6667 squared is 28.444 0.441 all over 3. And when we, so 781 plus 0.4445 plus 28 plus 0.4441. And we'll divide that by 3. So our standard deviation, or sigma, equals 16.8889. Right? And so you might be thinking, right, what does this mean? Like, what does standard deviation mean? So that means, like, how consistent your data is, right? The lower your standard deviation is, the more consistency your population has, or your sample has, if we did a sample one. So that means that, like, it's, a lower one means that say this is the data point, right? A lower one means that all the data will be extremely clustered, right? But a high standard deviation will show, it's really spread out. It's really random, a lot of outliers, and just really random data. So that shows the consistency of your data. So I hope this was useful. And also, we did not do a sample problem, or a problem for the sample standard deviation, but the process is exactly the same, except that you just use different variables, and the bottom is n minus 1 instead of just n. Okay, I hope this was helpful, guys.